Hi, my name is Aaron Lefkowitz and I'm one of the co-authors of the SQLBoiler library. Today I want to show you a little bit about how to get started with it. So the first thing we need to do is get the SQLBoiler package as well as some extra dependencies. One of these is going to be the UUID package. This is required for using UUIDs in your database. We're also going to get the null package, which is used by SQLBoiler to represent nulls in the database. The last one is just a logging package that I'm going to use for the demo. Now that we have all our dependencies, the next thing to do is set up the database. I'm going to start by creating a user for the database. I'm going to use the password test. The next thing I'm going to do is create the database itself using the user that I created. Now I load the database. If we take a look at the database schema, we'll see pilots, airports, languages, jets, and pilot languages. You can also see that we're declaring our foreign keys using the pilot underscore ID. This is the table name followed by underscore ID. SQLBoiler names your relationships using the foreign key name. If your foreign key ends with underscore ID, underscore UUID, or any of these other variations, you're going to get cleaner names in the end. Now that our database is set up, the next thing to do is to create the project that we're going to use. I'm going to create this under my GitHub username. The next thing we're going to do is create a go_generate statement in our main. This will actually call SQLBoiler with the parameters that we pass it, which in this case is just Postgres. Now we need an SQLBoiler config file. I'm going to put in the Postgres block the DB name, which is flight, then the username, which was boiler, the password, which was test, and finally the host, which is localhost. Now we can run go_generate and we can see that our models are generated by SQLBoiler. If you look, there's also a boil main test. SQLBoiler generated models include tests by default. These are compatibility tests that you can run against your database to ensure that your database is compatible with SQLBoiler. So we're going to run these compatibility tests now using -v to show that it's actually doing something. And as you can see, everything passes for us. That means we're okay to use SQLBoiler in our project. Now we're going to switch to our editor to finish our program. I'm going to create a logger using that log package that I downloaded earlier. This is just so we can have some output while we see what's going on. The next thing to do is to connect to the database. So we'll call SQL.open. This is the regular SQL.open and has nothing to do with SQLBoiler. The parameters of this function need to come from the actual SQL driver that you're using with Go. In our case, it's libpq, so I'll specify a connection string that works with that. Because it's an import that's not referenced directly, I need to import it manually. Go imports does the rest. Now we're going to handle the error that comes from the database connection. Now the first thing that we're going to do is create a pilot. The pilot object comes from our models package that was generated by SQLBoiler. We're going to give it a name. He's going to be named John. And now we're going to insert him into the database. You'll notice that I have to pass the DB handle into most calls. This is an alternative to using the G syntax. Insert G uses the globally defined database, which is set by using boil.setDB. This can be more convenient, but probably shouldn't be used in larger programs, as it's hard to test and dependency inject. We're going to print out the inserted pilot's info so we can see that the p.id attribute of the struct is actually being auto-incremented from the database. Now we're going to actually run the program. So we say go run main.go, and you can see that we connected to the DB, and we've inserted a pilot whose ID is 2. If I run it again, his ID will be 3. Now the next thing we want to do is actually retrieve the pilot back out of the database. In order to do this, we'll use the models.pilots helper. We're going to use the limit query mod and the onFinisher. The limit query mod attaches a limit statement to our full SQL statement, And the one finisher, make sure that we only get a single pilot back instead of a slice of pilots. So when we run this program now, we see it connects, inserts, and fetches, but you'll notice that the IDs are different. This is because we've already inserted many and we didn't specify which one we wanted. So in order to get the original back, we can use models.findPilot to specify an ID that we want to retrieve from the database. We'll print out the fact that we got the pilot back and make sure that we use the original.id to see that the IDs match. When we run the program again, we'll see that the inserted ID is the same as the found ID, even if the fetched ID is still going to be 1. The next thing we want to do is try our hand at relationships. One of the things SQLBoiler makes very easy is relationships. So we're going to create a couple jets here. When I call addJets, I'm going to pass true as the second parameter. This tells addJets to also insert the related objects, as well as associate them. If I already have objects that are in my database and I simply want to associate them, I can pass in false here instead. When we run this program, we'll see both jets get inserted. 1 and 2 are the IDs. What's not apparent from this output is that our jets were actually associated to the pilot. So now we're going to use the jets relationship helper on the pilot itself and call .all on that to retrieve all the jets that are associated to this pilot. Now we're going to do a for loop and loop over the jets that we got back from the query. One of the things to notice is that this is just like normal Go code and doesn't require anything special once we have the jets back. When we run this program, you can see that there's a created add date that we didn't input. Created add is managed automatically because we used created_at as a name and it's a time-related field. The other thing that you can see is that we got both of our jets back using the relationship helper. Their IDs are 3 and 4 because this is the second time that we've run a program that inserts 2 jets. This concludes the screencast. I hope you learned something about SQLBoiler and saw how easy it is to get started with. Enjoy boiling your databases.